Good morning, good afternoon, good evening, everyone listening. Today, we are going to cover the second webinar presentation on the series of the 2024 Solution Webinar Series. We welcome you all. We are going to begin shortly. Before that, I would like to see you the housekeeping slides from where you can download and from where you can ask the questions to our analyst.
Hello and good day everyone. Welcome to the 2024 Solutions webinar series. Before we start, there are some housekeeping information that I would like to share with everyone. Kindly do refresh the page if you can't hear the audio or if the slides are not moving. Widgets such as the slide area can be maximized and minimized according to your preferences of the layout. You are encouraged to send in questions during the webinar through the Q&A box. If there's insufficient time, speaker will follow up on those unanswered questions via email right after the session. We would also appreciate if you could give this webinar a rating on a scale of 1 to 5, with 5 being the highest. Presentation slides can be downloaded from the resource list along with other relevant articles as well. There are also links to useful resources such as the Automotive Events Calendar site where we list out all the upcoming webinar sessions. On-demand videos can also be accessed via this site as well. And for updated information pertaining mobility, please do refer to the Mobility News and Assets community site where contents are constantly updated to provide you all with the latest information. Also, do join our Automotive Insights and Analysis LinkedIn group where we facilitate the sharing of insights, data, and knowledge across market segments that will impact the automotive industry.
So thank you for listening patiently. Let me start the presentation. Today is 16th April 2024. This is the second presentation in the webinar series, and this we are going to talk about the Emotor Technology and supply chain evolution. I'm the moderator Gaurav Pangal, Associate Director for the Light Vehicle Production Forecast for Indian Subcontinent. With me today is joined by Karthik Ganesh, who is our Senior Research Analyst, Supply Chain and Technology. Karthik comes from the background of Mahindra and FAV, and he has a very wealth of experience in the propulsion technology side. And he's going to speak today about the Emotor technology. And with him, Piyush Garg will join us as a senior research analyst on the propulsion technology. Again, he understands the components very well, the fuel cells and the e-motors. So whatever question you have to our experts, please feel free to write in the Q&A section, and we are going to cover this for the next 1 hour. To begin with, let me introduce S&P Global Mobility first. As a Standard & Poor Global, we have 5 divisions which market, and together they deliver unmatched breadth and depth of the market. So we have this Standard & Poor Global Market Intelligence, we have S&P Global Ratings, which you must have heard. We have S&P Global Mobility, from which this presentation is running. So then we have the S&P Global Commodity Insights, and we do have the S&P Dow Jones Indices. What we do in the how we can help into the transformation side in the automotive disruption, and I think all the experts today are busy in discussing the transformation and the disruption in the automotive industry, whether it's a sustainable net zero impact, what governments are looking for, whether it's a supply chain issues, whether it's a retail transformation, whether it's a electrification or shared mobility. I think all our experts are quite occupied with the with the briefings what we can provide to our clients on these topics. And if you need any support from us, please feel free to reach out to us, and you can reach out from the Q&A sections, or you can also write at the askmobility@spglobal.com. how we can bring the unmatched credentials. I just wanted to reinforce here that we have 100% of the top automakers as our client. We have approximately 100% of the top auto suppliers as our client. We have over 900 plus automotive experts, those who are analyzing, reading data day and night in each technologies. We have over 1,000 data sets, and we have approximately 100% in the of OEMs in the United States also using our Carfax as the CPU programs. So to begin with this presentation, I would like to have ask you some questions on this topic before I hand it over to the Karthik and Piyush. I just want you to become a part of this survey and just answer this question: which motor technology do you see as the most popular form of e-motor technology going forward? A, permanent magnet synchronous motor with REE. B, permanent magnet synchronous motor without REE. C, current excited synchronous motors. D, induction motors. E, axial flux motors. Please do respond to the poll, and we can let you know what will be the results, what is the audience view on it, and then our experts will also go to give the view about their understanding. I'm still waiting for your replies. Okay, last 10 seconds. Okay. So this is the answer what we got. We believe that audience believe that permanent magnet synchronous motor without rare earth elements is 36.4%. That is going to be remain most popular technology going forward. Then the 31.8 is the permanent magnet synchronous motor with rare earth elements, and then induction motors. Oh, sorry. Then axial flux motors with 18.2% and induction motors at 9.1%. So the audience expects that permanent magnet synchronous motor without rare earth elements are going to be the most popular form of e-motor technology going forward. So then we move to the second question of the survey. Which winding technology would be the most widely adopted in the future? A, insertion round wire. B, concentric spool. C, hairpin U-pin. D, continuous hairpin. E, I-pin. I repeat the question: which winding technology would be the most widely adopted in the future? Please provide your answers. We are going to share the poll results in next 20 seconds. Okay. So let's move to the answers. This is the answers what we have received. Continuous hairpin wave S winding is the second most, 30 with 31.6%. The highest is the hair U-pin 40 with 42.1%. I think our experts are looking at the answers very closely right now, and I think they're going to take you through what are our analysis on this answer, and what we believe that what kind of winding technology will be adopted in the future. So from here on, I just bring my colleague Karthik and Piyush. I just hand it over to them for the presentation. Karthik, can you please start your presentation and please take through the exciting presentation what you have.
Sure, Gaurav. Thanks a lot. Hello, everyone. Nice to have you here on the webinar. So through the course of this presentation, my colleague Piyush and I would be talking about the technology and supply chain evolution that's coming about in this particular domain. Let me start off by touching upon the agenda for the session. So we have three main sections that we would be talking about. The first aspect covers drive technologies. We'll look at certain key attributes that are driving changes in motor and subcomponent design, and understand certain unique use cases that are developing in the world of e-axles when it comes to different vehicle segments. In the second part of it, we'll have a look at critical materials, where we'll try to understand the industry's perspective on the long-term viability of usage of certain critical materials. We'll look into a couple of scenarios that indicate how we could potentially reduce the dependence on rare earth elements, and have a quick look at how copper demand is likely to evolve over the decade, and then understand how the motor investments in the world of e-motors are happening across the globe. The third and final section would look into the supply chain dynamics of the e-motor world. We'll dive into the hot debate that is coming about at this point in time about in-house versus outsourcing strategies for e-axle and some of its subcomponents. Therefore, finally, summarizing the presentation that we will put forth. Getting right into the presentation now, it's important to first set a context of the market that's evolving across the globe. So the chart you see in front of you indicates that up to 2035, the e-motor market is likely to grow significantly, with a production volume of approximately 122 million expected in 2035. This market size is almost triple that of the market that existed in 2023. And as we see here, we see that by 2035, 84.6 million units are devoted to e-axle motors, which is a significant driver of the growth of the entire e-motor market. This is because e-axles have become a go-to solution when it comes to battery electric vehicles. In 2035, e-axles are expected to command about 70% of the total market, which is a significant growth from 38% that it had in 2023. Other kinds of motors, such as non-e-axle based on, say, belt or transmissions, will reach their peak in 2028, with just over 46 million units being produced annually. Now, in this global context, when we talk about India, India is expected to account for about 7% of the total market in 2035. And of this 7%, 42% is likely to be captured by e-axles itself. When we talk about technology, there are a few key attributes that are gaining a lot of attention right now in the e-motor domain, which are driving designers to think on their feet and develop new technologies. One such attribute is specific power. It has emerged as a pivotal parameter and warrants thorough consideration when coming to the design of a motor. The intent is to optimize the power output in relation to the size and the weight of the motor. So as you see the chart on the right-hand side here, it indicates how specific powers have been evolving across generations of motor technology. And we have noted that across the industry, 35% improvement in specific power is observed. Now, as we talk about different suppliers, this usually falls under a band between 20 and 40%. Suppliers and manufacturers are looking at alternate means to achieve these incremental gains when it comes to specific power rating. The first approach that's commonly used is to augment the power while maintaining the same weight of the motor. The second approach entails maintaining the same power rating but reducing the weight of the motor. And there is a third approach where in parallel, the power of the motor is increased and the weight of the motor is reduced as well. With further changes coming in the future and moving from, say, current generation to the future generation of e-motor technology, we do expect further increase in specific rating to come in as well. It's important for us to understand why specific rating plays a crucial role when it comes to e-motor design, because high specific power helps us in generating higher output with a smaller and much lighter motor. This overall contributes to a better energy efficiency. A more power dense motor means less energy is wasted, which translates to overall higher system efficiency, which further helps us increase the range of the vehicle for the same battery capacity. This has significant gains and helps manufacturers extend as much as possible. And if you look at the chart at the bottom on the right-hand side, we do see that across different motor types as well, incremental improvements have been brought in the industry over a period of time to ensure that specific ratings can be increased significantly. Now, if we further uncover some trends that exist within specific rating, we do see that PMSM motors have the greatest of specific power rating when compared to other types of motors. While a designer might choose to move from PMSM to an induction motor, they would want to ensure that they achieve the same power rating that the PMSM motor possesses. So while this is possible, but there are certain trade-offs that need to be made in the form of weight or efficiency. So the chart on the left-hand side here indicates a scenario for three different suppliers who wish to move from PMSM to induction motors. So when we talk about supplier one, we do see that supplier one is able to move from a power rating of close to 100 when it comes to the PMSM rating to the power rating of close to 100 for an induction motor as well. But when we look at the weight of it, the weight nearly doubles. And we do see the bubble size, which indicates the specific power rating significantly coming down. So the trade-off is clearly evident for supplier one. Now, if I talk about supplier two, the idea for supplier two is to maintain the specific rating as close as possible. Thus, they're able to increase their power and slightly increase the weight of the motor as well, but are within a close range of the original specific power. Supplier 3 indicates a very different strategy here, because in the hope of maintaining the same specific rating, supplier 3 has to move from PMSM to induction motor with a much heavier motor, which almost weighs 140 kgs and has a much higher rating of 300, so that the same specific rating can be maintained. Multiple strategies are being adopted by different suppliers based on their know-how, and these indicate that their designers in particular have to be very wary of the trade-offs and accordingly choose the best strategy that fits their use case. The chart on the right-hand side gives us an indication about how the current motor and mass trends are moving. And as I indicated, of the three possible approaches that could be adopted, the third approach, that is increase in power output while reducing the weight of the motor, is something that is picking up a lot of steam at this point in time. So we do see a downward trend coming in where a lot of increment in power is observed and a significant reduction in the weight is also observed. When we talk about motors as a whole, it's important to assess what kind of a motor comes on board an electric vehicle, because efficiency is of paramount importance. We do see that over a period of time, permanent magnet motors are likely to be the most dominant form of motors going forward. This is primarily attributed to the fact that the peak efficiency of these motors is too high for manufacturers to basically pivot away from such technology in large volumes. Although there are suppliers who are actively working to try and find alternate solutions such as externally excited motors or induction motors. Last year, Tesla announced that they would be developing rare earth-free permanent magnet motors, which are likely to be targeting low-cost variants. Similarly, in North America, General Motors and Stellantis have also invested heavily in this area to ensure they can develop rare earth-free motors. Now, if we look at the 2035 market, about 76% of the e-axle market is expected to be powered by permanent magnet-based motors only. Of the outlook, when we do a global look at it and break it down based on regions, we see a different understanding that comes to us. We see that different regions are likely to adopt different types of motors. If we look closely on the right-hand side, Greater China is expected to continue the usage of permanent magnets that use rare earth elements. This is driven down to the fact that Greater China has access to abundance of rare earth elements, which makes it a viable solution for them to pick up and go forward. However, if we look on the middle and the left-hand side of the chart, Europe and North America are pivoting away from the PMSM motors with rare earth elements and are looking at alternate solutions that could help them. This is primarily driven by the fact that they want to reduce their dependence on certain raw materials which are regionally restricted, and thus Europe taking up more of electrically excited synchronous machines, and North America picking up permanent magnet motors which are rare earth free, and the use of induction motors. Now, in the Indian market context, we believe that over time, as the uptake of EVs increases, India is likely to follow a mix of strategy that exists in North America and Europe, with certain segments being more popular in India. Rare earth-free permanent magnet motors are likely to attract a lot of attention in the market. So all this talk about permanent magnet motors leads us to one question: why permanent magnet motors? So it's it's actually important for us to assess and understand that these motors hold certain advantages, which is why they are called the go-to motors in the EV space. So if you see the spider chart on the left-hand side, four most common motor topologies are taken into consideration with about 5 critical attributes which are considered thoroughly before evaluating which motor to go ahead with. PMSM motors score highly on 4 attributes out of 5, except for the cost advantage part, and thus are taken forward in the industry. So typically, a permanent magnet motor offers much higher efficiency due to the use of permanent magnet motors, unlike other motor types. This permanent magnet produces a stronger magnetic field and ensures a higher power density. And since this type of motor is not dependent on external sources for excitation, unlike some of the other motors we have taken here for comparison, this further leads to better energy conversion and a longer range, which is a direct effect of the superior efficiency they possess. Over the past decade, there has been a significant amount of development and improvements that have come about, which ensure there is an increase in the performance, the durability, and reliability of permanent magnet motors. The relatively high cost of these motors is attributed to the fact that they make use of rare earth elements, although used in lower quantities, but are still on the expensive side. This unmatched combination of power density, efficiency, and proven reliability makes permanent magnet motors the go-to solution for suppliers and manufacturers in the EV space.
Piyush? Karthik, I think you got freeze or Piyush, are you there? Can you hear me?
Yeah, I can hear you, Gaurav. I think looks like
Karthik got disconnected. Maybe he so let's wait.
maybe, yeah,
Let's
maybe we
wait.
can just make a few seconds for him.
Yeah, let's wait for him. Maybe he must be refreshing. Just bear with us. I think we got some technical glitches at Karthik's end. Just wait for a while. We understand till the time I can see the questions coming from multiple people already. We are going to take this Q&A after the presentation of Karthik and Piyush. Maybe you can, Piyush, can you call Karthik on this? Well, he's already here.
And there was some issue with the browser and crashed.
Yeah, Karthik, I think you're back.
I hope I'm audible now.
Yeah. Yes. Your connection looks slow to us.
Hope I'm audible.
Yeah, you're audible. You're audible. Your face is, yes. You can switch off your camera and you can speak. Meanwhile, I can help you. Please go
Sure,
ahead. Yeah.
no problem. So,
Yeah, we can hear you now. Perfect.
all right. So, okay. So, as we were talking about some parameters that influence performance of electric motors, one parameter that has been looked at in detail nowadays is the speed of the motor. So, designers are trying to explore how increasing the maximum speed of an electric motor could drive certain gains towards power density and efficiency. For a long period of time, 20,000 RPM has been seen as a limit or a boundary within the industry when it comes to mass manufacturing of electric motors. Recent developments in the space have helped push this limit further to as high as 30,000 RPM. This is thanks to better thermal management and certain improvements in mechanical design, which have played an absolutely crucial role. When we talk about the India market, by 2035, we expect 19% of the e-motor market to be powered by motors that can run at speeds greater than 20,000 RPM. The second key attribute that is being discussed a lot when it comes to design of the system is efficiency. For an electric vehicle, efficiency is of paramount importance for several key reasons. A system that's more efficient is likely to use less energy when it comes to maintaining the same performance. This promotes longevity of the battery and also enables the possibility in the future of having a smaller battery pack. If we look at the chart on the right-hand side here, it basically indicates motor efficiency trends that exist in the market as of now. The red line basically indicates the peak efficiency, whereas the bar charts indicate the efficiencies of different suppliers in the current market. So the idea for different suppliers or manufacturers is to try and bridge this gap that exists between the benchmark that's indicated in red and the actual values that can be seen in the bar charts. So PMSMs can easily achieve efficiency levels ranging from 94 to 98%, while ESMs and induction motors have an efficiency band that is quite wide, ranging from 89% to 96%. These values of efficiency are heavily dependent on design, operating conditions, and control strategies that are implemented in it. If one were to move from the first two types of motors, that is the induction motor and the externally excited motors, to permanent magnet motors, one can achieve an improvement of about 2 to 5%. In parallel, the use of silicon carbide based inverters can yield significant improvements, thereby enabling higher system efficiency. So the idea is to ensure that such subcomponents can be optimized to the best level so that when all of the system comes together, we have an overall higher system efficiency. A key parameter that is assessed while talking about system efficiency is winding technology. So performance of an electric vehicle hinges on the use of the appropriate winding technique, as they directly impact efficiency and the overall driving performance. The spider chart here indicates 4 common winding technologies used within the axles and categorizes it based on 6 different key attributes. And we do see that hairpin winding is one of the most famous or the most high-scoring type of winding when we compare these 4. So over time, hairpin technology has matured and is gaining the recognition for its combination of high efficiency and high power density. This is primarily due to the fact that these winding technologies have a high fill factor, and in parallel, the design of the windings is in such a way that the losses are much lower, which thereby enables an improvement in efficiency. The manufacturing complexity that's associated with the hairpin windings is relatively higher when it compared to, say, traditional winding techniques. However, we do know that they offer a good balance of manufacturing efficiency and high performance. Since hairpin windings is able to strike a good balance between high performance and cost effectiveness, this particular technology has positioned itself as the go-to technology when it comes to winding selection in electric motors for electric vehicles. To give you a glimpse of how the market is likely to evolve, we have a couple of charts put out here. So if we look to the chart on the right-hand side, as indicated, E-axle growth previously as indicated, E-axle growth is a very significant parameter in increasing the growth of e-motors across the next decade. This further drives the growth of hairpin technology as well. The regional breakdown on the right-hand side here shows that all regions are likely to adopt E-axles as much as possible and are likely to adopt hairpin winding as well, so that they can optimize their performance and ensure a good torque characteristic at high speeds. And due to these particular parameters, they are likely to be the most preferred choice for manufacturers. Now, if we talk about India, we see the chart on the left-hand side indicates that in 2023, India had a large chunk of insertion winding available in the market, but this decade, it's expected that the volumes would be eaten up by hairpin windings due to some of the benefits such as high power density and high efficiency these winding technologies possess. While e-axles are a significantly important topic of discussion, the growth in in the electric vehicle market is also bringing in new use cases for these particular e-axles. So if you look at the chart on the left-hand side, large volumes are primarily driven by cars and SUVs, which will continue to use e-axles. However, there are certain segments such as pickups, MPVs, and vans, which also require e-axles, but with a unique use case. So these different segments are likely to account for about 15.5 million e-axles in 2035. Three quarters of which is for vans and pickups in particular. So this calls for a unique application which can cater to the specific demands of these particular segments. So the adaptation of an e-axle based on such a market demand has led to the development of e-beam. E-beam is basically an adaptation of e-axle for a more robust use case where it has a similar offering as that of a solid beam axle used on an internal combustion engine vehicle with a motor packaged into the axle itself. Due to the unique loading and towing requirements, this technology is considered as a practical solution for pickups and vans and is also viewed as a faster and a more affordable way for electrification to ramp up in these two particular segments. The chart on the right-hand side gives us a view that by 2035, we will have 2.1 million units of e-wheels produced in 2035. This growth is primarily driven by the pickup market that exists in North America and closely followed by the van market in Greater China. One of the leading suppliers of e-beams at this point in time has already won over certain contracts in India as well for big OEM who will be using the same in one of their pickup applications that's due to come into the market in the next couple of years. To cap off this particular section, I will quickly run you through the regional production trends of motors that are existing at this point in time. The chart in front of us indicates that when going from 2023 to 2030, there is a good indication of growth of regional production of motors for different markets. All these markets are expected to grow because of the increase in EV uptake being the primary driver, with China leading the way as the biggest EV. Another is leading to increasingly regional production is supply chain. A great example of this transition in supply chain is a phenomena called nearshoring, where suppliers have shifted their base from different parts of the world to the North American region so that they can categorically cater to the North American market. So through shifting of these bases to North America, these suppliers and OEMs are able to secure their supply chains in the event of a regional crisis. We expect India to follow a similar trend to meet the needs of the EV industry in the coming decade. And by the end of current decade, we expect about 500,000 motor units to be produced in India. As more and more announcements come into play, we expect more plants to be set up, more localization to occur, and a significant amount of volume to increase as we go forward. I would like to now hand over to my colleague Piyush, who will take you through the parts on critical materials and provide an outlook on supply chain. Over to you, Piyush.
Thanks, Karthik. Thank you everyone for joining in here. So my name is Piyush and I'll be taking you forward towards the critical raw materials and the supply chain aspects of the propulsion technology. So starting with this one, first, when we deal about the concern in this industry, we know that one of the primary concern in the industry revolves around the possibility of facing the supply chain constraints of the rare earth material. The reliance of these materials for various technologies raises the questions about the long-term availability and the sustainability. So notably, there is a discernible shift going away from the rare earth dependency in the technology, and the major players like Tesla and BMW are spearheading this shift, prioritizing the alternative technologies to reduce the reliance on the rare earth materials. For instance, they have made significant strides in the area incorporating induction and externally excited motors. And And one of the notable development that happened recently was a Tesla announcement in 2023 regarding the development of the non-rare earth-based magnets as well. This innovation marks a significant step toward mitigating the concerns in the long-term availability. And when we look and speak of the market trends, when we look into the global aspects, the magnet consumption starts at about 82% in 2023 and experiences a gradual decline reaching by 79% by 2033. And the non-magnet based motors begins at about 18% in 2023 and shows a steady increase reaching the in fact 23% by 2035. Overall, there is a shift away from the magnet consumption towards non-magnet alternatives over the specific period of time. And these trends reflect evolving global manufacturing dynamics influenced by the technological advancements. When we compare that with India, we see that in Indian magnet consumption starts notably higher from the global average. That is currently 97% of all the motors being used in Indian EVs are magnet based in 2023 before gradually declining it to 82% by 2033. And the non-magnet based motors starts at mere 3% in 2023 and significantly lower than the global average, but catches up to 18% by 2033. The convergence of India's usage proportion of the global figures over time indicates a shift toward alignment and with the international manufacturing trends. And these trends underscores India's evolving landscape in adaptation of the global market dynamics. In this slide, we are exploring an interesting prospect of reducing the neodymium consumption through a sort of a scenario analysis in basically the traction motors outside the Greater China. Neodymium, as we know, is a rare earth element that faces fluctuations in availability and the market price, making its consumption reduction a very crucial consideration for the manufacturing practices. In the below graph, there is a baseline for the non-rare earth based magnets in blue color. And we have tried to analyze a scenario when installation of the non-rare earth based magnets is done in each of the secondary axle. So it shows that it can be forecasted that about 19% reduction in neodymium consumption is expected in 2023. And this reduction is further going to increase to up to 29% by 2035, indicating a significant potential in minimizing the reliance on neodymium traction motors. There are few points that I want to convey regarding the material quality, that selecting a higher quality material for the new motor core windings and laminations can lead to reduced losses and enhanced performance. And however, it is essential to acknowledge that the high material cost often comes with a higher cost, which may impact the manufacturing expenses. There is a positive environmental impact to it, but overall in this analysis, the assumption that we have made that it is important to note that analysis assumes that all the magnets use a similar level of neodymium as a caveat. Going forward to another aspect, that building upon the previous analysis, we wanted to explore a further granular scenario where we assume that all the A, B, and C segment vehicles are transitioned into non-rare earth based magnets. So these scenarios aims to assess the potential for further neodymium consumption reduction beyond our initial projections of the previous one. And these motors are specifically for the vehicle with the lower power requirements, typically under 100 kilowatt, which are common in all these segments. The projection in reductions, what we can get through it is about approximate that moreover this transition to rare earth based magnets often facilitates a weight reduction as well. And we see that by implementing this, we can get about 8% reduction in the neodymium consumption further. Also, there is one more important point to note that approximately 2% of the motor weight is linked to the neodymium usage, meaning weight reduction initiatives will naturally yield further reduction in the neodymium consumption as well. So by leveraging non-rare earth based motors and focusing weight reduction improvements, manufacturers can achieve a substantial gains in sustainability and the cost effectiveness. Here in this slide, we are going to delve into the intricate dynamics of the copper demand with electric motors, focusing specifically on the E-axles. We all know that copper plays a crucial role in E-motors, primarily within the rotors and stators, influencing performance and efficiency. And the intensity of the copper usage in E-axle motors fluctuates based on the factors such as motor type and the winding technology. Generally, increased power corresponds to a higher demand for the copper within the specific motor type. And in permanent magnet synchronous motors, the demand for copper primarily arises from the stator winding. Whereas when we speak of the induction motors and EESM motors, they exhibit higher copper intensity due to utilization of the copper in both stator and rotor components. Hence, there are some optimization strategies that are being used by the manufacturers. To enhance the copper utilization efficiency, manufacturers often optimize the techniques, how they use the winding. For example, one of which being the rectangular wires. These rectangular wires enable the better fill factor, maximizing the space between the motors and optimizing the copper usage. And what we see, the transition or the impact from using these technologies, that transitioning from round wire to hairpin can lead to significant reduction in copper usage, typically ranges from 0.25 to about 5.5 kg. And when we look into the copper demand based on the aspects of the global demand of the copper projected in tons, what we see that it is projected to increase from about 100,000 tons in 2023 to about 600,000 tons by 2035. India seems to be following the same suit, where the demand is expected to rise from about 900 tons in 2023 to about 10,000 tons by 2029 to further 20,000 tons by about 2035. In summary, this analysis shares the copper demand in e-motors, and it's going to increase gradually over with the advancement in technology as well, and how manufacturers want to utilize or they can optimize with different technologies being implemented, and how they can tailor the consumption of the copper. With this slide, we are trying to explain that what kind of investments are going on around the e-motor space, whether they are the material and the partnerships that are happening around the globe, and how the investments are increasing across the India and Asia subcontinent. So when we speak of it, in North America, BMW I Ventures invested about $27 million in recycling rare earth elements, emphasizing a sustainability and resource conservation. Neuron Magnet secured about $25 million with Samsung Ventures, Ellison Transmission, and the Magna for development of the Korean earth magnets, contributing to the advancement of magnet technology. In South America, Arnold Magnetic Tech collaborated with Cycling Materials that focuses on establishing a rare earth element recycling supply chain and promoting the circular economy principles. GM's partnership with Vacuum Schmills aims to secure reliable supply chain rare earth magnets, aligning with their strategic objectives of sustainability and operational excellence. Polestar MOUs with Cyclic Materials underscores the commitment in incorporating recycled rare earth elements into their supply chain. In Europe, Solvay's investment in rare earth element plant in La Rochelle demonstrates a commitment to vertical integration and securing a sustainable supply chain. ArcelorMittal's e-steel plant in Mardyke which is going to be online by 2024, signifies an investment step towards the decarbonizing e-steel production and supporting electric vehicle manufacturing. When we speak of the Japan and Korea, MP Materials agreement with Sumitomo establishes a reliable rare earth element supply chain, essential for development of the advanced metro technologies. And JFE Steel investment in e-steel capacity highlight the industry transition towards this manufacturing practices and reducing carbon emissions. Similarly, in India, there have been significant investments like NIDEX, $55 million investment in Karnataka, and Schaeffler's capacity expansion in Vadodara signifies growing investment and commitment in the electric motor industry in India. Also, ZF's investment in new plant in Orgadam underscores the region's potential as a manufacturing hub for the electric vehicle components. So in conclusion, there has been a lot of investments going around all the regions with a global commitment toward the advanced electric motor manufacturing technologies. With the next slide, I would be diving into supply chain aspects of the technology. Starting with this one, this slide covers the implication of the OEM's vertical integration with the e-axle system, where we are trying to encompass the integration, overall system integration, including a motor assembly, rotors, and stator components. Here our analysis focuses on trend of the OEMs transitioning toward the greater vertical integration. Currently, OEM's vertical integration in e-axle motor supply chain stands at 4.42%, indicating the extent to which OEMs manufacture or control the various components internally. And our analysis projects a reduction in OEM vertical integration in coming years, declining from 42% to about 34%. This trend reflects a shift towards outsourcing certain manufacturing processes. Components potentially are driven by the factors such as cost optimization, technological advancement, or the supply chain efficiency. Projected reduction in OEM vertical integration suggests increased reliance on the external suppliers in some of the aspects or the component in the EXL system. And while this may streamline the operations of and reduce the operational overheads for OEMs, it also introduces dependencies on the external supplier. One point that has to be considered in these are the basically opportunities what OEMs can gain through these collaborations. And overall, in conclusion, the assessment of the OEM's vertical integration in the EXL system underscores the evolving dynamics of the marketing strategies within the OEM industry and how they are trying to balance their capabilities, partnering with the external suppliers, and how they can optimize their supply chain. Now let's look into another evolving dynamic of the EXL production, particularly the shifting of the roles of the OEMs and the supply chain in design, integration, and the production. There has been continuous increase in the OEM involvement from recent years. The design and integration of the EXL motors are increasingly become domain of the OEMs, reflecting a strategic shift towards the in-house capabilities and control. This trend highlights OEM desire for the greater control over product development, performance optimization, and the intellectual property. Despite this increase of the OEM involvement in design and integration, electric motors are subcomponents such as rotors and stators, which are also present as significant opportunities into the supply chain. And as the EXL volume increases over the period of time, there's a growing need to diversify the supply chain aspects. With around 60 million EXLs projected to be produced in around 2035, the supply chain plays a crucial role in system integration. And OEMs are increasingly leveraging the supply chain, adopting a print-to-build approach where the OEMs owns the entire design but relies on the external partners for production and integration. Taking 2030 as a reference, the levels of OEM in-house production are estimated to be about 68% for the system integration. And in conclusion, the evolving landscape of the EXL production underscores the shifting roles of OEMs and the overall supply chain. In this slide, we are further diving a little bit deeper into the previous analysis, going into a more granularity, where we are considering both system integrator and motor integration. The level of in-house production decreases to further 45%. This indicates that while the OEM maintains the control over the system integration, they rely more on the external suppliers for the motor components. The further next slide covers another deeper aspects. In this slide, while incorporating not only the system and the motor integration, but also the production of rotors and stator components, the level of in-house production decreases even further to 34%. This comprehensive assessment really reveals that the extent of OEM in-house capabilities and significant opportunities are available for the suppliers supplying the e-motor components. In conclusion, the granular analysis overall helps us explain that OEM's in-house production levels underscores the evolving dynamics of the EXL production landscape. While OEMs maintain the control over the system integration, they increasingly rely on the external suppliers for the motor components, presenting significant opportunities going forward. In this slide, we will be discussing about the strategic consideration regarding the in-house production versus the outsourcing in the context of EXL production. First, about the system integration. System integration of the EXL is projected to remain predominantly in-house production out to 2030. And this reflects OEM's desire for control over the integration process, ensuring alignment with the performance standards. Second, in electric motor design, in contrast to the previous one, there's a notable trend toward OEM bringing the design of electric motor in-house. However, OEMs are increasingly looking to outsource the production of either of the entire motor or the specific subcomponents. In inverters, it appears to be mostly strategically sourced, and trend is likely to be followed due to the domain-specific know-how and expertise lying with the suppliers in these areas. Strategic sourcing, some OEMs are opting for strategic sourcing, leveraging their external supplier expertise and production capacities while retaining control over the design and IPs. Alternatively, OEM seems to be looking for the alliance or joint ventures with specialized motor manufacturing facilities through which they want to access the control of the advanced production capabilities and expertise. In conclusion, the strategic approach to the EXL production involves a nuanced balance between the in-house integration and the outsourcing, tailored to meet the specific need and objectives of each OEM. Looking into the aspect of regional dynamics of the strategic sourcing strategies for EXL production, it is quite imperative to consider the trends in anticipating shifts in the various global markets. What we see in the current landscape is that in 2023, Japan and Korea experienced substantial equity alliances in EXL production, reflecting a collaborative approach to enhance technological capabilities and the market competitiveness. And when we look into the anticipative trends, it looks like going forward by 2035, we anticipate that in South Asia and Europe, they will be following the similar suit with increased number of equity alliances for EXL production. And these regions are likely to leverage the partnerships to strengthen their supply chain resilience and foster the innovation and also capitalizing the market opportunities. Whereas in North America, a contrast can be seen that North America is expected to continue prioritizing the in-house sourcing strategies for EXL production. And these approach align with the region's focus on maintaining the control over the manufacturing processes and intellectual property. The choice of sourcing strategy, what we believe, is basically being influenced by some of the factors like including the market dynamics, technological capabilities, also the regulatory environments, and also supply chain resilience of the region. So in conclusion, regional sourcing strategies for the EXL reflect a dynamic interplay of the market forces and of course how a particular region looks into technological aspects and the strategic imperatives. In this slide, similar to the previous Emotor one, we are trying to explore the strategic consideration regarding the in-house production versus outsourcing of the key subcomponents of the EXL, like rotors and stators. When particularly for the rotor production, the production of the rotors for the EXL motors is expected to remain predominantly in-house out to 2030, and likely due to the preference for maintaining control over the critical components, ensuring the quality performance and intellectual property protection. Similarly, for the stator design, OEMs typically design stators in-house, emphasizing customization and alignment with the specific performance requirements. However, the increasing complexity of the winding technologies might lead to a rise in outsourcing, for example, specifically for the hairpin winding and the continuous wave windings. So as a result, OEMs are increasingly turning to the strategic sourcing and alliance or joint ventures to outsource rotor stator production while retaining control over their design and IPs. Yeah, that's all from my side. I'll further request Karthik to take over and help us through the summary.
Thanks, Piyush. So as we went through the different slides that were put across, we can summarize and have 6 key takeaways from the presentation. The first one talks about the axle market. There is a significant amount of growth that's coming in motor production, primarily driven by e-axles, and this roughly translates to about 85 million units by 2035. While talking about design and development of e-motors, power density and efficiency are 2 hot topics which are warranting a lot of attention, and with these specific parameters being optimized further, there is a lot of scope for further improvements in efficiency. Rare earth magnets, while the most efficient and go-to type of motor choice, potentially have certain supply chain related issues which may arise as we move forward. So there are plans afloat to explore alternatives in terms of motor topology as well, and the fact that there are options to move away to rather ferrite-based magnets as well. When we talk about the supply chain part, larger OEMs are expected to continue a trend of vertical integration. As indicated, roughly 60 million e-axles are expected to have about supplier involvement in 2035. The electric motor, the inverter, and the subcomponents such as rotor and stator are emerging as key points or key targets rather for the supply chain as the volumes of e-motors increases over the next decade. The final point that the final takeaway we have is that as different segments come into play, there are different use cases that will evolve for e-axles, and we will need to look at the different technical solutions that can help get cheaper motors for affordable vehicles, and also ensure we get different applications for different market segments. So that's what we had to present over the webinar for today. I would request Gaurav now to please take over the Q&A. Over to you, Gaurav.
Thank you, Piyush. Thank you, Karthik, for summary. Thanks for your presentation, guys. Let me go without wasting any time. Let me directly go to the Q&A because we have multiple questions on the audience. So this is the first question which is coming. It has been indicated that the different region would localize motor production. Do you think OEMs are more likely to do this in-house, or will they need to really on supplier to meet the necessary volumes? So what you suggest, guys?
Yeah, I'll take that one. So yeah, what
Piyush,
as per
I
the
think
indicate,
go Piyush, yeah.
yeah. So as per the indication that yeah, there is certainly a shift that OEMs are trying to localize as much as they can, because when the engine's going away, they want to utilize their production capacities, they want to utilize all the manpower and also technological aspects, and also improve their margins. So basically,
Piyush, can you please
with a
repeat?
big, am I audible?
Yeah. Please repeat the
Yeah.
answers from where you were repeating.
Okay, sorry. So yeah, certainly what we think that with the engines going away, that OEMs are trying to utilize their production capacities and also the manpower and the technological advancements, the resources that they have, spare resources. So they are trying to develop motors more and more in-house in the region, from the region to
Mm-hmm.
region, so that they so that they can also make up their cost and also improve upon their margins. So this is one aspect of looking into it, that they are
Mm-hmm.
trying to make they are trying to make more and more components, and particularly motors specifically in-house. One of the key examples could be BMW and Volkswagen, which are trying to integrate vertically thoroughly. And but yeah, there are
Mm-hmm.
certainly some of the aspects of the margin as well, where this based on the numbers of the certain vehicle nameplate or brand, they are trying to outsource it so that it makes more sense to them to outsource it and save some cost. But yeah, going forward, the trend is likely to be seen of going more in-house strategies. That's what we project.
Okay. I think we have removed a few related questions to this also, but let me come first to the another important question which is coming around. How do you see the market for rare earth free motors evolving globally? I think this goes to Karthik because he was talking about this. So Karthik, can you take this one?
Yeah, sure, Gaurav. That's a great question. So we do foresee that there will be a bit of shift towards this particular segment, but maybe not immediately. It will happen gradually, and in the next decade, will be the time for say mass adoption of such technology will have a certain say disadvantage particular topology carries at this point in time, which if catered to would put this across as a very good alternative and a alternative which will ensure that manufacturers, as they try to
Karthik,
go
sorry to interrupt
more,
you.
say,
But
yeah,
I think your voice is cracking. Can you please switch off your video and then again repeat the answer?
is it better now?
Yeah, this is better now.
Okay, so when you talk
So
about
we were
rare
discussing
earth
that how
elements,
do you see the market for rare earth free motors evolving globally?
yes, understood. So as we, at this point in time, we do see permanent magnet-based motors as a more go-to solution. But over
Yeah.
the course of the next decade, we do see significant shift coming in because the fact that a lot of raw material comes from a specific region only makes it difficult to secure that particular raw material when it comes to production of such motors. So if there are alternatives such as rare earth free elements, which certain suppliers are already exploring, which is through, say, ferrite magnets, possess an advantage, but also possess more disadvantages at this point in time. So the fact that the motor has to become much bigger or loses out on efficiency or power rating is something that is too crucial at this point in time for supply.